Hello and welcome. Today we're going to look at Geometry Section 7.2, Similar Polygons. Definition: two polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. Picture here, polygon ABCD and EFGH. For them to be similar, all of the angles must be congruent, the corresponding ones. A is congruent to E, B is congruent to F, C is congruent to G, and D is congruent to H. Along with that, we must also have the sides being proportional. So side AB has to be in proportion to side EF, BC has to be in proportion to side FG, CD has to be in proportion to GH, and DA has to be in proportion to HE. If both those things are true, then we have similar polygons. And we would write that, the little difference here, our new symbol, would be similar, just a little tilde thing here. This means similar. We've talked about equals, we've talked about congruent, and now we know that we have similar. And here's another statement with another picture, the same thing that we have. This kind of gives a visual representation for the ratios, or the sides being proportional. Down here, the corresponding sides are in a 3:1 ratio. Alright, use a similarity statement. So we have, if triangle ABC is similar to RST, list all the pairs of congruent angles and write a proportion that relates the corresponding sides. So we know that all the angles are congruent. Okay, and they have it mapped out. We have A and R are congruent, B and S are congruent, and C and T are congruent. Alright, we write that out here under the congruent angles. This proportion follows suit as well. We have AB over RS, BC over ST, and AC over RT. And that's all we're looking for, is taking the similarity statement with the triangles ABC similar to triangle RST and writing out all the congruent and proportional parts. Same thing happens here, writing similarity statements. Pentagons JKLMN and STUVW are similar. List all the pairs of congruent angles, write the ratio of the corresponding sides in a statement of proportionality. So this will be on our test. We'll be asked to do this following task. So I would just match up my letters: J and S, K and T, L and U, M and V, N and W. Those are all of my angles that are congruent. Once I have those listed, then I want to talk about my sides. And my sides can just go systematically as well. J, K, S, T, K, L, T, U, L, M, U, V, M, N, V, W, and then J, N, and S, W, as we have down here in the bottom. Okay, so listing of all of the angles and all of the proportional sides. So this is basically a record-keeping problem. As long as you can do those and write that properly, you should have no issues on the quiz. Next question: comparing similar polygons, decide whether the figures are similar. If they are, write a similarity statement. If they're not, then show that they're not. We know that we had to have all the angles being congruent in both the figures to be true. So if I match up here, W and P are congruent, X and Q are congruent, Y and R are congruent, and Z and S are congruent. So I have half done. All of the angles are congruent. But now I must have a proportion statement of all the sides. So if there's any one side that's not in the same ratio as another, then we're not going to have the two figures being similar. So as I'm looking around here, I have just taken, for instance, WX over PQ. That's 15 over 10, and that's equal to 3 over 2. I have XY over QR, that's 6 over 4, which is also in a 3:2 ratio. I have WZ over PS, which is 12 over 8, and that's in a 3:2 ratio. And I have YZ over RS, and that's a 9:6, which is also in a 3:2 ratio. So seeing as that all the angles are congruent and all the sides are proportional, yes, these two figures are similar. my similarity statement, WXYZ, similar to PQRS. Alright, same question here. Decide whether the figures are similar. If they are, write a similarity statement. So I can flip around my triangle here to match on this one. Have it pointing this way. And then I'll take a look at my proportions. And I have NL over PQ is equal to 12 over 4, that's 3 over 1. But looking at ML over RQ, I have 10.5 over 9, which is 7/6. And since 3 over 1 is not equal to 7/6, I know that this cannot be similar. So taking a look at the figure there. So not similar between the two polygons. Alright, using similarity statements, quadrilateral JKLM is similar to quadrilateral PQRS. Find the value of Z. So I have Z on top here, QP. It's in the same spot as JK, which is 10. So I can write a little proportion based off of the fact that I have similar polygons. My proportion I can write is that KL over QR is equal to JK over PQ. Putting my numeric values in there, 15 over 6 is equal to 10 over Z. And from section 7.1, I know I can cross multiply and solve. 15Z is equal to 60, which implies then if I divide 15 on both sides that Z is equal to 4, which is what I was trying to solve for. So using the fact that I have similar polygons, I can solve for side lengths on them. Next example, similar type problem. Parallelogram ABCD is similar to parallelogram GBEF. Find the value of Y. So I have a parallelogram within a parallelogram. I can find a proportional relationship, GF over AD. GF over AD is equal to EF over CD. And I can plug in the values there to end up with 15 over 24 is equal to 12 over y. Cross multiply, 15y is equal to 288, and y is equal to 19.2 when I divide then. So again, writing this initial proportion is the key, and then it's just a matter of algebraically solving. Alright, two polygons are similar. Find x and y. Same type of idea. I have y plus 2 and 8 in the same spot. I have x and 3 in the same spot, and my constant is 6 and 4. So I have 6 over 4, and I'll have two different proportions that I set up. So I write the proportions to find x and y. I have AB over RS is equal to CD over TU. So that means that 6 over 4 is equal to x over 3. Cross multiply and solve. I have 18 is equal to 4x, and x is equal to 9/2. Using the same method on the right, with the right section here for y, I have AB over RS is equal to DE over UV, which is 6 over 4 is equal to 8 over y plus 1. Cross multiply and solve. And I have y is equal to 13/3. So again, putting the similarity statement together, or the proportions from the fact that we have similar polygons, is the key. A couple more here. Alright, first one says the two polygons are similar, solve for A. So I have A in the spot of 4, and I have 3 and 5 being in similar spots here. So I'm going to go with 5 over 3 is equal to 4 over A. Cross multiply, 12 is equal to 5A. When I divide both sides by 5, I end up with 2.4. So A is equal to 2.4, and that is one of my choices, choice C. So A is equal to 2.4. Second question, the two polygons are similar, solve for B. So now I'm going to look at B here. B minus 6 is in the same spot as 2, and I have my 5 over 3 again. So my proportion will be 5 over 3 is equal to 2 over B minus 6. Cross multiply, 6 is equal to 5B minus 30, Add 30 to both sides. 36 is equal to 5b. Take 36 divided by 5, and I have 7.2, which is my value for C. And of course, C is my solution. Good. Alright, next section here. Scale factor is the ratio between corresponding sides of a similar polygon. Let's apply that statement. The rectangular patio around a pool is similar to the pool as shown. Calculate the scale factor of the patio to the pool and find the ratio between their perimeters. So we both have a rectangular pool and rectangular patio. We can find the perimeters of both of those, then to justify or to figure out the scale factor from that. So finding perimeter, we know that this side's 32, that means this side's 32. This is 16 and 16. Same thing happens out here. 48 and 24 on both sides here. So statements, we have a 48 to 32 scale factor, or sorry, a ratio between the large outside of the rectangle and the inside rectangle, which is a 3 to 2 ratio. We can go ahead then and we found the perimeters by taking 2 times the lengths that are given to us, 2 times 48 plus 2 times 24, and then 2 times 32 plus 2 times 16, which gives us our perimeters of 144 and 96, and then it's also in a 3 to 2 ratio. So we have the sides in a 3 to 2 ratio, and we have the perimeter in a 3 to 2 ratio. So we calculate the scale factor of the patio to the pool, and now we follow the ratio of the perimeters. We notice that they're the same, that the scale factor and the ratio of the perimeters is both 3 to 2, which leads us to the statement, theorem 7.1, if two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding sides. And here's that statement again. Okay, now that we know that, let's apply that. If ABCD is similar to RSTUV, find the scale factor of ABCD to RSTUV and the perimeter of each polygon. So find the scale factor, we gotta take the sides that we know, which is at A or VU, which is 4 over 7. And that's gonna be equal to DC over 10.5. We can figure out what DC is. DC is equal to 6. Once we know that DC is equal to 6, we can find the perimeter of the two figures by filling in the information we know. This side's going to be 6, this side's going to be 4, and then we can just sum it together. So the perimeter of ABCDE is 6 plus 6 plus 6 plus 4 plus 4, or 26. And 4/7 is our scale factor. So the perimeter of ABCD is equal to the perimeter of RSTUV. So therefore the perimeter of the other figure is going to be 4/7 equals to the proportion of 26 over x. Cross multiply, and x is equal to 45.5. So the perimeter of the second figure is 45.45. So again, repeating that, we're able to find the perimeter of this figure. It was equal to 26 because we had this side and this side being 6 from which we solved, that side being 4. We know that the scale factor between figure 1 and figure 2 is 4/7. So the perimeter of 26 in a proportion with 4/7, right? Ratio of the small side with the small figure, big side from the big figure. We can cross multiply and solve for the perimeter there for 45.5. Good. Last problem, similar statement. If LMNOP is similar to VWXYZ, find the perimeter of each polygon. Okay, we have to note the things that are similar in both. We have ZY and PO. So we have a ratio of 8/6, which simplifies down to 4/3. From the top figure, we know that we have 8 over here and 16 here for a perimeter of 8 plus 8 plus 12 plus 16 plus 16. So 8 and 8 is 16, plus 12 is 28, plus 16 is 44, plus 16 is 60. So the perimeter of the top figure is 60. And if we just looked at our list here, we know it can't be A, B, or C because elemental P is 60. But to show that we do have 45 as the perimeter of VWXYZ, we have 60 over the perimeter of the unknown figure, X, equal to the ratio between the two figures, which is 4/3. Cross multiply, and we have 180 is equal to 4x. And when you divide 4 from 180 divided by 4, you're going to get x is equal to 45. So our final answer is D. Oh, and it went to the wrong spot here. I'm sorry about that. Should be down here at T. Okay. That ends lecture for today. The questions that we're going to look at tomorrow will be from page 469, numbers 8 through 28.